Day calculus class. We're going to kind of finish off this section 4.3. Section 4.3 is so crucial to our work moving forward in calculus. Um, I don't think that I actually got the graphs drawn. So if you want to take a look at these graphs, maybe you want to pause the video and draw these graphs down in your notes. That might be helpful to you. And as I print this document, which is a scanned document, as a PDF, when I print it as a smart notebook, I don't get the best results. So I copied over it with blue marker, doing my best here. But let's talk about when you look at a graph and you're looking at first derivatives and second derivatives. Remember that a function is increasing wherever f prime of x is greater than 0. So as we look at this graph, you can tell it's greater than 0 here and here. So therefore, we're looking from, let's see, 1, 2, 3, 4, 5. It's increasing from -5 to 2, union with, well, I'm sorry. My bad. Okay. -infinity to -5. That's where it's above the x-axis. Union with, let's see if I can count that. 2, 3, 4, 5, 6, 7, 8. Looks like 2 to 8. Looks like it's decreasing in the other places, so wherever it's below the x-axis. So I'm looking at here, and I'm looking at here. So I'm decreasing from -5 to +2, union with 8 to infinity. So we can tell a lot about the function. So when we say where is it increasing, we're not wondering where f prime is increasing. All this is telling us about the function f of x. This is all indicating to us about f of x. We can also determine local max. Local max is where f prime changes from positive to negative, and changes from positive to negative at -5. And then also changes from positive to negative at 8. The local min is wherever it changes from negative to positive, which is going to be at 2. And we can't come up with the y value. So we know the x values, but we can't come up with the coordinate because we don't have the original function to plug it into. So let's talk about concavity. Concave up is where f double prime is positive, or f prime is increasing. So as we look at this, you can see that as I draw this in blue, this is where f prime is increasing. That's where f prime is increasing. Or in other words, where the derivative of the derivative is positive. So those blue lines in that situation, they represent the second derivative. So it's concave up. It looks like from -1 to 1, 2, 3, 4, 5. I think I've got 5. I'm really struggling to tell with the graph there. I'll check this graph just to be a little bit better off. Oh, looks like it's 6 if we look at that, guys. So we'll make that change. So we got -1 to 6. So concave down wherever the first derivative is decreasing. So you can see it's going to be from -infinity to -1, union with, then we've got from 6 to infinity. That's where it's going to be headed down again over there. So the inflection is wherever it changes concavity, and it changes concavity at -1 and at x is equal to 6. So if you would like to go ahead and try the next one on your own, go ahead. We're going to roll through it here, but maybe you want to press pause and see if you can do this. But again, we're wondering where is f of x increasing, decreasing, concave up, concave down, local min, local max, and inflection given the graph of f prime of x. So given f prime of x, where is f of x doing those things? Well, it's wherever f prime of x is greater than 0. So that would be from -8 all the way over to 2, union 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Union 10 to infinity. And decreasing from -infinity to -8, union with 2 to 10. Local max is wherever f prime changes from positive to negative. That's going to be at x equals 2. Local min is wherever f prime changes from negative to positive. And that's going to happen at x is equal to -8 and at x equals 10. So now as we consider concavity, wherever f prime is increasing, so you notice it's increasing here, but it's decreasing there. So it looks like it's increasing right here. So that'll be from -infinity, 1, 2, 3, 4, 5, 6 to -6, union with -4 to -1. That section. 1, 2, 3, 4, 5, 5, 7. And then union from 10 to infinity. You can see it ends up being a lot when you look at all those pieces. Concave down is going to occur wherever the second derivative, or wherever the first derivative is decreasing. So look at these green spots I'm drawing here. That's where the first derivative is decreasing, or f double prime is negative. Looks like from 1, 2, 3, 4, 5, 6, -6 to -4. 5, all the way over to 5. Is that what we have? 1, 2, 3, 4, 5. Did I mess that up? Should have been, instead of -6, should have been maybe -5 or +5. Oh, no, it's right there. It's 5. 1, 2, 3, 4, 5. So from -1 to 5. And then that short little clip, 1, 2, 3, 4, 5, 6, 7, from 7 to 9. Inflection is wherever it changed concavity. Looks like it changes concavity at all of these maxes and min spots. That's where it changes from increasing to decreasing, or decreasing to increasing. So 1, 2, 3, 4, 5, 6. Looks like x equals -6, -4, -1, 2, 3, 5, 7, and 9. Lots of inflection points. We're not going to do this one over here, but we are going to do this one. Now we're looking at f double prime of x. And for f double prime of x, that doesn't tell us anything about increasing or decreasing. And it doesn't tell us if we have where we have the local max or where we have the local min. But f double prime of x does tell us about concavity. And so in this situation, f of x is going to be concave up wherever f double prime is greater than 0. F double prime is greater than 0 here and here. So 1, 2, 3, 4, 5, 6, 7. So -infinity to -7. Union 1, 2, 3, 4, 5, 6, 7, 8, 9. 4 to 9. And then it's concave down wherever f double prime is negative. So this is the graph of f double prime. It sits below the x-axis from -7 to +4, union 9 to infinity. Inflection happens wherever it changes sign. So that's going to be x equals -7 and +4. there you have. So you know your graphs of first derivatives and second derivatives, they give you information about the original function f. You just have to know what you're looking for and what you're limited in finding. So um, now that gives us a great opportunity to look at some AP problems. So these are some AP problems so since like 1965, they've released, I don't know, like 15 or so multiple choice exams. And each exam has about 45 questions. And I've had a really good time going through every single one. And yeah, it's a lot of fun. So let's go through some tough AP questions here. And your assignment is going to have a couple of these AP questions. See how you do with it. Okay. 2012. So this is a problem. It's problem number 80 from the 2012 exam, and you were allowed to use a calculator. And the first thing I want to notice, you're given a graph of f prime. You always want to look at what graph are you given? F prime, f double prime. This is f prime. So it says the graph of f prime, the derivative of the function f is shown above. Which of the following statements must be true? F has a relative minimum or a local minimum at x equals -3. Well, minimum happens where f prime changes from negative to positive. If you notice the derivative, it does. F prime changes from negative, it's negative down here, and then it's positive up here. So that one works. The graph of f has a point of inflection at x equals -2. So it kind of looks like it changes from concave down to concave up. Kind of looks like this is an inflection point. But remember, the graph of f has an inflection point. That would be saying f prime as an inflection point. We're not talking about f prime. Remember that an inflection point occurs when f double prime changes sign. So if you're looking at this graph of f prime, notice it goes from increasing to decreasing. So actually the inflection point is going to happen at 0. So this is not true. And then the graph of f is concave down from 0 to 4. So concave down is where f double prime is less than 0. So 0 to 4, let's look at the second derivative. Yep, looks like f prime is decreasing, which means that f double prime is less than 0 from 0 to 4. So this one is correct as well. So we're looking at 1 and 3. 1 and 3 is the answer. So just to let you guys know, it's, you know, if you were to get, say, a score of 65% on the AP Calc exam, that would score you a 5. Okay, so on a score 1, 2, 3, 4, 5, that would score you 5. In fact, if you get a score of 50% on the AP Calc exam, scores you a 3. So it is a challenging exam. People don't get, you know, just all the questions right. The graph of f prime. So again, we given a graph of f prime is shown. Function f has a local maximum. So local maximum occurs when f prime changes from positive to negative. And where does this graph change from positive to negative? It would be right there at 1. So the answer is C. The graph of f double prime is given. When is the function concave down? So again, we're given f double prime. So I'm looking, where is f double prime less than 0? Well, f double prime is less than 0 here and here. And so that would be from -2 to -1, and then from 1 to 3 as well. So the answer is E. Let f be a polynomial with values f prime selected. Which of the following must be true between -2 and 6? So if you look at these f prime values, it looks like each one is positive, okay? Looks like these are positive here. It says the graph of f is concave up, okay? The graph of f has at least 2 points of inflection. F is increasing, f has no critical points, and f has at least 2 relative extrema. This is a complicated question, and try to help you understand what it means. There's no guarantees. You see here that at -2, f prime is 3. So to give you guys an idea of what that means, if you just think about a graph, At -2, it has so it's got a slope of 3 at that spot. And then by the time you get over to 0, it's got a slope of 1. Okay, so slope of -2 and then a slope of 1. Okay, that's kind of what's happening. You can tell it kind of looks like it's concave down there, so to speak. But I'm going to draw you another graph that has those same properties. Okay, so 1, 2. So it has a slope of 3, and then it's got a slope of 1. You don't know what happens for a value of -1. It could have an f prime value of -2. You don't know that it stays positive the entire time, okay? You don't know that it stays positive the entire time, okay? You don't know that. But here's what you do know, okay? What's happening to the f prime values? It looks like it's dropping. So that means that f double prime is negative there. And then it looks like it's increasing, which means that f double prime is positive. It looks like it increases again by 3, which means f double prime is positive. And then all of a sudden it drops again. That means that f double prime is negative. So it went from negative to positive to positive to negative. That's what happened to f double prime. And if the second derivative changed sign twice, that means it has 2 points of inflection. You can't guarantee it's concave up. It's concave up for part of the time, but not necessarily the whole time. You don't know for sure if it's a lot of people pick this one because they see that f prime is positive the entire time. Well, like I said, it is possible for graph to do something like that, so it'd be actually decreasing at that spot. So you don't know for sure. No critical points, you don't know that, and at least 2 relative extrema, we don't know that either. Let's look at this last one. Polynomial f has selected values of its second derivative. We're given second derivative here, okay? And remember, so every time you see second derivative, you think about concavity and concave up, concave down, you think of inflection. So those are the things that you want to kind of come to your brain when you see that. And it says, which must be true? F is increasing? Well, second derivative doesn't tell us about increasing. Decreasing? Second derivative doesn't tell us about decreasing. F has local maximum. Again, F double prime doesn't tell us about local maximum. Hey, inflection and concavity. Now that's in my wheelhouse. I like that. That's what F double prime can tell me about. So it says the graph of f has a point of inflection at x is equal to 1. Well, let's see. It goes from positive to 0 to negative. Okay? So that's interesting. So it looks like it changes sign, but I want to be very clear that it doesn't tell you what happens at 0.5. For example, 0.5, it could have a value of, say, 3, and so it'd be positive. But it could also be true that then, say, at 1.2, it could have a value of 3, and at 1.8, it could have a value of 0. So you can see in this situation that it is dropping in value there. So it doesn't necessarily mean that just because you see the 0 there, that that's where the inflection is. So we gotta be careful. Look at this one. It says the graph changes concavity somewhere over the interval of 0 to 2. So it's positive here, it's negative here. So somewhere in between here, it must change concavity. Whether that happens at 0.5, whether it happens at 1, whether it happens at 1.3, somewhere it does change concavity. We just can't say it's for sure at 1. So therefore, E is your correct answer. Anyway, those are some higher level questions. We're going to get to our next section later on called curve sketching. It's a really good time. I'm sure you're going to do great with it. Hopefully that lesson helps out. Can't wait to see you guys soon. Have a great day. Bye.